Sorry, I know it's really confusing, but he's climbing this blue route, and I just want to say I'm not much of a rock climber. In fact, if I tried any of these movements, I would be about 3 feet shorter because I'd be in a wheelchair. I thought rock climbing was very interesting because it's the only environment where you have these very complex biomechanical interactions in a very short period of time. And to build an AI model that can truly understand the human body and the interplay between various limbs, I thought rock climbing, training it to climb a bunch of walls, was a great way to figure that out. So there's more videos, but I'll show that to you later. But real quick, this is a pretty big diffusion transformer model. It's trained in a very similar way to a lot of text-to-video models or video models in general. But in this model, it takes in 2 inputs. One is environment frames. What that means is that most of the videos for people engaging in sports or activities is just YouTube videos of them, actually doing the activity, right? So there's in part of the pre-processing step, there's a model that essentially removes the person from each frame in the video, and you get a bunch of clean frames that depict the environment to climb. And then the other input is context frames, which depict the route to climb. It goes in this diffusion model, and then you get a bunch of parameters that when you visualize it on each frame of the video, you get an AI guy rock climbing. So what exactly is being predicted here? It's not the pixels. It's actually parameters for this parametrized 3D body model. It's called SMPL, Skin Multi-Person Linear Model, and it takes in 2 parameters, pose and shape. And any combination of those 2 parameters can give you basically any possible human body. So it's a really efficient way of representing the human body. And this model, basically predicts pose and shape, as well as a bunch of other parameters that I'm not going to get into, that help it visualize the corresponding mesh onto the respective video frame. We have 2 minutes left. All right. So I'm going to dive deep into the actual diffusion model, or the transformer model. So this is basically a vanilla diffusion transformer, but with cross attention. But instead of like a typical text-to-video models, the video frames are taken in directly as conditioning into the cross attention block, and the time step is the only thing that gets put into the MLB block. And similar to most text-to-video models, they're spatial and temporal blocks. I'm sure that's how Sora is trained. I'm sure that's how a lot of big video models are trained, spatial blocks and temporal blocks. Nothing too crazy going on here. And so I'm gonna go back and talk more about what exactly is being predicted. So how it works is it doesn't actually predict the full body mesh. The body mesh is calculated afterwards. It predicts its pose and shape, and it also predicts various other things like the bounding box and 3D camera, and all those parameters are then put into another model that creates that mesh and then displays that onto the video frame. So it's not actually predicting the raw pixels of that human body model. It's predicting parameters that will then get visualized onto the frame, which is how you get that mesh thing going on. But yeah, this is, there are a few more examples on the website, but frankly, it doesn't generalize that well. It generalizes very specific climbing environments. It works somewhat in outdoor climbs as well as indoor climbs. But yeah, I think this is a very promising approach to helping AI systems understand the human body, because rock climbing is very complex. And if you can get an AI to rock climb, you can get it to do anything. So